Okay, in the third quarter, the first topic, good morning students, by the way, we start the third quarter with the basic of electrostatics. And the static means, by the way, we deal with the stationary charges, and as you understand here, it's written as electron, so it's related to the charges here, and you know that the smallest charge that we know is called as electron. It's denoted by E and the minus sign over it, and the charge of this electron is minus 1.6 10 to the power of minus 19 coulombs. And as you see here in the picture, the electron is vibrating around the nucleus. This part is called as nucleus, and the whole picture here is called as an atom, you know, and that's an electron. It's vibrating around it. By the way, the mass of electron, if we need it, is 9.11 10 to the power of minus 31 kilograms. And the particles that are inside in the nucleus are called as, both of them are called as nucleons, since they are placed in the nucleus. But separately, that's positive charged particle is called as proton, and the neutrally charged, I mean the charge of this is 0, is called as neutron. We'll come up to this later maybe, but the charge of proton is the opposite of the charge of an electron. It's positively charged, and that's why it's not minus, it's plus 1.6 10 to the power of minus 19 coulombs, and the mass of proton is 1.64 10 to the power of minus 27 kilograms. The charge of neutron, since it's neutral, you see here neutral, it's 0, but the mass of neutron is a bit massive than the mass of proton. It's 1.67 10 to the power of minus 27 kilograms. And these charges are forming now the atom here. Of course, by the way, since the only particle that moves is an electron, I want you to know that if anything is moving, it's an electron. The protons are strongly connected or tied to a nucleus, so that's why they are not moving. It's very hard to separate them. And of course, mostly we deal with the electrons, with the negatively charged particle, and we continue with the electrifying materials. There are three ways to electrify any material. Electrifying materials. There are indeed three ways. The first one is called as rubbing, as you see in the picture. So the rubbing, as you see in the first picture, when you rub a woolen cloth to a plastic rod, you rub it, and the plastic rod will be negatively charged, and the woolen cloth will be positively charged. And you see here that the number of negative charges here is as -4, and the same amount of plus charges will be formed in the woolen cloth. In the second picture, you see here, when we take a silk cloth, and we rub it with the glass rod, you see here the glass rod will be positively charged, while the silk cloth becomes negatively charged. And again, the amount of charge on both sides are equal. This method is called as rubbing. When you rub anything to any material, first, for example, when you rub your comb, you know what is comb? When you rub your comb into a hair, it becomes charged because of the rubbing, and that's the first way of electrifying any materials. So you see here that both of the materials are becoming charged. This one is negative and this one positive, but here it's opposite. Here it's negative and here it's positive. Okay, the second way is called as contact. Let me write here that is the second way to electrify any material is called as contact. So, as you understand, when you take any charged particle, any charged material, sorry, and you connect it with the conducting material, so the materials that easily transfer any electrons or any, charges through them are called as, erase it, it's a bit different, are called as conductors here. So conductors, they conduct, they can pass, any charge through itself. So you see here these two spheres. One of them was charged as 6 plus 6q. Let me assume that I have 6 positive charges here, excess of positive charges here, and you see here, by the way, they both become by 3 charges here, plus 3q from both sides. So they share the charges here equally because the sizes of these spheres are equal. So you see here, if I take the radius of them, of these two balls, they are equal. So in the third picture, you see here that if we take and if we connect them with the wooden rod here, the charge will not pass through it. So these materials as wood here are called as insulators. Okay, when any two charged materials, so assume that I have Q1 here and here I have Q2, and after some while it becomes Q1 prime, after contact, and that is Q2 prime. How they share any charges here. So the formula for this is easy. Q1 prime will be equal to Q1 plus Q2 over R1 plus R2 and times R1. And the same logic is present to the Q2 prime, Q1 plus Q2 over R1 plus R2 and times R2. So that's the formula, how they share the charges. And by the way, the charges here, if you look at the picture here, I have here, as I see, minus 10q, and the charge of the second sphere is 0. So you see here the sum of this, if I take the contact, if I bring them into contact and then separate, they share by equal amounts here, by minus 5q here, but the total charge here, as you see here, it's minus 10, here it's minus 10, and here it's minus 10. So the amount of charges before and after, let me write here q1 plus q2, as you see here, minus 10q plus 0 equals q1 prime, that is minus 5q, as the sum of minus 5q. You see here again, the sum is minus 2. So that is constant, it's conserved. So this law here is called as conservation of charge. So the second way you see here to electrify any material is called as contact. When you take any charged particle and bring into contact to a second material and then separate, they share their charge relative to the radii, you see. And the third way to electrify any material is called as induction. What is it? What you do, you see here, when you bring any, by the way, before we bring close, we just bring close, we don't touch it here, we just bring close any charged material. You see here, since the negative charges here attract, by the way, positive charges, you see here, since I have here minus 5q, you see here, and they attract here plus 5q. By the way, let me write here that same charges repel. They don't like each other. You see here that minus 5 repels minus 5 to the farthest end here, and by let me write here that is like charges. That means same. So unlike charges, like negative and positive, they attract each other. You see. So that's the rule that you know from the 8th grade. And now I have here minus 5q, and minus 5q are repelled to the far stand here. And if I connect it to the ground by a wire here, I have the conductor here, and I connect it to a ground. You know what is ground? Gerda. If I connect it to a ground, the negative charge will flow, and then I just cut it here. I cut the wire. You see here, my sphere becomes now positively charged, and I just take it away, this rod, and now my sphere becomes positively charged. By the way, before, when I bring it close, this rod, before this attraction, the sphere was completely neutral. I mean, the sum of plus charges and negative charges will be same. I mean, that will be total charge here will be equal to 0. I mean, total charge before this one. But since I bring it closer, this negative charge attract positive, and then the negative charge will move to the ground by a wire, and when I cut the wire, it becomes a positive charge. This method is called as induction method. Okay. The next thing that I want to share with you now is related to the, you see here, device that we call it as electroscope. An electroscope is the device which shows if an object is charged or not. So you see here, it consists of metal knob here, sphere here, and it's connected to a conductor with the leaves here. You know this, what does leaf mean? Leaf, indeed, it has in the trees here we have leaves, so that's called as a leaf. We have two leaves here, and it also consists of insulating here glass tube here, and of course insulating legs here, and this one is called as an electroscope. So why do we need it? We'll see. Suppose that I have again an electroscope. Of course the sphere is not drawn here, but the main thing is here that is we have a metal knob and conducting here rod, and then two leaves here. Suppose that I have a positively charged rod. I bring it close, I didn't touch it. You see here the positive charge attract negative. Indeed here the number of positive charge should be +4, as you see here in the picture. And since it attracts here, unlike charges attract each other, it attracts here negative charge here 4, and the 4 charges, since like charges repel each other, go to the far stand, I mean to the leaves. Since these both leaves here, they are positive, they repel each other, you see. So since they repel each other, so leaves indeed before the charging they were vertical, then now they diverge. We call it as diverge. You see here, it becomes the angle has increased here, but before the contact, before when I bring this charged rod to the electroscope, both of the leaves were vertical. Now they diverge, and when they come closer, we call it as converge. And in the second picture, you see here that we have a positively charged rod. We make it contact. We bring it into contact. You see here the positive charges will flow. Of course, again they diverge. Of course, the angle of diverging here depends on the number of charges here. If I have, for example, from both sides, if I have by maybe 3 charges, it will diverge more. You see here the angle increases here. Of course, since I have here alpha 1 and alpha 2, of course the alpha 2 is greater than alpha 1. You see? if I have free charges from both of the leaves here. And for example, if I just bring it to contact, for example, suppose that I have steel here. Oh, let me raise it a bit. Suppose that now I bring closer. I brought into contact, for example, a negatively charged rod. Suppose that I have minus charges here, and let it be -4 here. And now the number of positive charges on the leaves now decreased, so I have the angle here of alpha 3, and you see here it's less than alpha 1. You see here it's less than alpha 1 because I have one charge from both sides here. If I bring it closer, of course it will cancel the 4 charges here. You see, they will cancel each other. Now they become neutral, and now I have the excess of 2 charges here, and since I have 2 leaves here from both sides, I have by 1 charge from both sides, so the alpha 3 now becomes smaller, of course, and alpha 3 is smaller than alpha 1. Okay, that's related to an electroscope. You see here, if I have a negatively charged electroscope here, I have 2 electrons from both sides, or electric charge, negative charge here, -2q from both sides, and here -2q. I have the angle here, alpha 1, and alpha 2 now becomes greater because the number of negative particles from both sides increase, so it will diverge more here. So alpha 2 is greater than alpha 1. And when I bring a positively charged rod close to this one, you see here, it will attract negative charges here, so now the angle becomes smaller, so it will converge here. I mean, the angle decreases here, of course. Now let's come up to an example. 2 identical metallic spheres of charge q1 -2 microcoulombs. By the way, we have the abbreviations here. That is millicoulomb, that is 10 to the power of -3 coulombs, and 1 microcoulomb, you see 10 to the power of -6 coulombs, and 1 nanocoulomb, that is 10 to the power of -9 coulombs here, and 1 picocoulomb, that is 10 to the power of -12 coulombs here. And you see here that is, I have here Q1, the charge of Q1 is -2 microcoulombs here, that is -2, 10 to the power of -6 coulombs. And Q2 is 6 microcoulombs here, that is 6, 10 to the power of -6 coulombs. The main things here, that is these 2 balls are identical. What does it mean? It means that R1 is equal to R2, and let me write as R. Since the radii, by the way, the plural form of radius is radii, since the radii of both spheres are equal, they will share this by equal amount. Let me see it. So I can easily write that since the total sum here is -2 plus 6, that will become 4, and they share by 2. So let me write Q1 prime is 2 microcoulombs, and Q2 prime becomes 2 microcoulombs here. Why do I get this? Because I know that the formula of Q1 prime is Q1 plus Q2 over R1 plus R2. Let me write as 2R and multiplied by R. I simplify this, and you see here the sum I have to divide by 2. By the way, since the radii are equal, of course that will be equal to the Q2 prime also. And since I have here -2 plus 6 and divided by 2, you see here that I have 2 microcoulombs from both sides here. Okay, 3 neutral identical conducting spheres K, L, and M are brought into contact, and then a positively charged sphere S is brought nearby. It's not into contact. Suppose K and M are separated by L by holding them by their insulating stance, and then sphere S is removed. What's the final type and the magnitude of charges on spheres K, L, and M? Of course, since I bring it close here, you see here that I have here let's suppose that I have here 4, 5, 6, 7, 8, 9, 9 negative charges here, minus 9q, will come up to this side. So this becomes negative. And of course, since why minus? Because you know that unlike charges attract each other, so the amount of positive charges attract the same amount of negative charges on this side here, so that is minus 9 here. Suppose that I have minus 9 here. And of course, the same amount will be repelled to the farthest end. And that will be plus 9q. So, and if I now separate them, the radii are same. That's my m here, that's L, and that's K. You have to understand that it will become minus 9q, and that's plus 9q. And L, now still it's neutral. So I brought it far away. As now I removed the S here. It's not here anymore, but this one becomes now minus 9q, this plus 9q, and n. And that is neutral. So this way is related to induction, and you understand here. It's not into contact. So the spheres now are charged by the way of induction. And you see here this logic you should apply to solve this problem. Okay, if you have any questions, please ask, and you can write on my YouTube channel as a comment, or you may write by WhatsApp if you wish. So thank you. Let's call it a day.